Hi everyone, we're going to learn the chain rule today. We're going to use the chain rule to find the derivative of functions that can be thought of as composite functions or functions inside functions. So the first one we're going to do is consider the function y equals x squared plus 3 all to the fifth. The chain rule says you can find dy by dx, which is y prime, by taking dy by du and multiplying it by du by dx. So it's suggesting a u substitution here, which is kind of how this is going to kind of be like the derivation, or you can see how the chain rule works, and then we'll just make it easier to do. So if I let u equal x squared plus 3, so I'm letting u be what's inside the brackets here, then I think we can agree that u prime, or du by dx, would be 2x using the power rule. Okay, so keep that in mind, that du by dx is 2u. And then we can think of y, if we're letting u equal x squared plus 3, we could think of y as being u to the fifth. And if we find dy by du, so differentiate with respect to u, we would get 5u to the fourth. Okay, so then it's saying that dy by dx is dy by du, which we said was 5u to the fourth, multiplied by, so times, that's not an x, but a time sign, du by dx, which we said was 2x. So these multiplied together. But u we defined to be x squared plus 3. So I can have this whole derivative in terms of x if I change u to x squared plus 3. And then multiply by 2x. And then what you would do to simplify it is you can multiply, because these are both monomials, 2x and 5, you can multiply them together. And you get 5 times 2x is 10x times x squared plus 3 to the fourth. So we don't want to have to do a u substitution and figure it out in parts like this every time we do it. So I'll show you how I like to think of it. So if we start off with what I call a power function, so something in brackets, all to a power. Okay? So we can find dy by dx, or just y prime, by first doing, it's like the power rule, we'll call it power of a function rule. So we can do 5 times whatever's in the bracket to the fourth. So that's kind of like applying the power rule, but we'll call it the power of a function rule. But I call this the outer derivative. So the exponent comes down, multiply by whatever's in the brackets, decrease the exponent by 1. Okay? Now we multiply that by the derivative of what's inside the brackets. So the derivative of what's inside the brackets is x squared plus 3. The derivative of x squared plus 3 is 2x. And that's going to be called the inner derivative. So the chain rule, it's the outer derivative multiplied by the inner derivative. And then again, these are both monomials, 5 and 2x can be multiplied together to give you 10x. And then times this part, which is, like, you can't multiply it in because it's all to the power of 4. And there it would be in simplified factored form. So we got the same answer as we got up here by using the definition of the chain rule, which says you can break down, you can find dy by dx by doing dy by du times du by dx. Okay? And then we broke it down into outer derivative times inner derivative as kind of the easier way to do it. So the chain rule can be expressed using the concept of the composition of functions. So if h at x is f composite g at x, you may not have done composition of functions, but f at g at x. So in our case, if we go back to the example up here, we would say that f at x was x to the fifth, and g at x is x squared plus 3. And then f composite g at x, which means the same as f at g at x, would be, so g at x, f at g at x, so it would be something to the fifth, and that something is g at x, x squared plus 3 to the fifth. So f at g at x, or f composite g at x, is x squared plus 3 to the fifth. And then you can see, they tell you the rule there, to find the derivative of this, which they're calling h prime at x, it's f prime at g at x times g prime at x. So again, if we think of it that way, if we let h prime at x then is going to be, so f prime at g at x would be that where we just leave the x squared plus 3 and use the power of a function rule. And then multiplied by g prime at x, this is g here, x squared plus 3, and the derivative of x squared plus 3 is 2x. So again, using that definition, we end up with the same answer. And I think of it as outer derivative multiplied by important, the inner derivative. Okay, so we're gonna practice a bunch of these and hopefully get good at them. So 1a, differentiate, so find the derivative of f at x equals x squared minus 4x to the sixth. So it's already expressed as a power of a function, so some function, x squared minus 4x to the power of 6. So it's ready to be differentiated using the chain rule. So first we're going to do the outer derivative, so that's going to be 6 times whatever inside the bracket to the fifth, there's the outer derivative, multiplied by the inner derivative, so the derivative of what's inside. So the derivative of x squared minus 4x would be 2x minus 4. And that would be the derivative. Okay, and that would probably be how the back of the book would write it. It's 3 things all multiplying together. We would not, in this case, combine the 6 and the 2x minus 4 because one's a monomial and one's a binomial. So you just leave it like that. Sometimes the back of the book would write it in ascending powers. So they'd have the 2x minus 4 binomial, which is just to the power of 1 first, and the one that's to the greater power, in this case to the power of 5 second, but they're exactly the same, so it doesn't matter. All right, in B here, it's not written as the power of a function yet. So you want it to be, we want to rewrite the square root of x minus 5 as x minus 5 to some power. And we know that the power for square root is the power of 1/2. So again, this is just y, we haven't derived yet. We just rewrote square root of x minus 5 as a power function, as x minus 5 all to the 1/2. So now when we derive, so we find y prime, the outer derivative, bring down the exponent 1/2 x minus 5 to the negative 1/2, reduce the exponent by 1, and then times the inner derivative, which would be the derivative of x minus 5, and that's just 1. And then we want to express that without a negative exponent. Since the question started with a square root, we want to express it with a radical. So left on the top would just be 1. In the bottom would be the 2, and then square root of x minus 5. All right. Next question. So for C, already expressed as the power of a function. So we can go straight to using the chain rule here. So y prime is going to be, outer derivative is 4 times 2x squared plus 3x minus 4 to the third. And then we have to multiply that by the inner derivative, so the derivative of what's inside the brackets, which is going to be 4x plus 3. And then we could leave it like that, or we can organize it so a 4x plus 3 binomial just to the power of 1 comes before the trinomial that's to the greater power. But again, it doesn't matter to me what order you have them in. D, if you look at D, you may think it's written as a power function, but it's not. We want to have whatever our power function is in the numerator, not the denominator. So using exponent rules, if I bring this up, it's going to be to the power of -4. So that's just f at x, just rewritten. So now we're ready to find f prime at x. So exponent comes down, -4 times 3x squared minus 5x plus 1 to the -5. You decrease the exponent by 1. And then we're going to multiply that by the derivative of what's inside, the inner derivative, which is 6x minus 5. And then we want to express our final answer with positive exponents. So the -4 is going to stay in the numerator along with the 6x minus 5 binomial because it's to the power of a positive 1. But we're going to put the 3x squared minus 5x plus 1 in the denominator, and instead of having an exponent of -5 in the denominator, it would have an exponent of positive 5. So that's simplified factored form again. Okay, on to E. So again, for this one, it's not as a power function yet. It's not something to an exponent, so we want to rewrite it as 2x squared plus 3 to the half. That's just y. Now we want to find, I'll just say dy by dx this time instead of dy prime. I mean, they mean the same thing, so it doesn't matter, but just show you that you can use either. So first we're going to do the outer derivative. So a half, exponent comes down, 2x squared plus 3 to the -1/2. That's the outer derivative. And then we're going to multiply that by the inner derivative, the derivative of what's inside. So that's going to be 4x. All right, and then when we simplify this, we do have monomials this time. So we can multiply the 1/2 by the 4x. And if you multiply 1/2 by 4x, you get 2x, and that 2x is going to be in the numerator. The 2x squared plus 3 is going to be in the denominator because it's to a negative exponent, and it's going to be the positive, or it's going to be to the square root of 2x squared plus 3. You could think of it as in the bottom it would be 2x squared plus 3 to the positive 1/2, which would be the square root of 2x squared plus 3. So that would be the answer as simplified as you can make it. All right, g at x for f here, first we have to write it as a power function. So we want to bring the 3x plus 4 up to the numerator, and the exponent would be -1/2. Because square root is 1/2, but we're bringing it up to the numerator, so it's -1/2. So now we're going to find g prime at x. So exponent comes down, -1/2 times 3x plus 4. Careful here, so it's -1/2 minus 1, which is -3/2. So again, -1/2 minus 1 is the same as -1/2 minus 2/2, and that's how you get the -3/2. But then we still have to multiply that by the derivative of what's inside, which is +3. And then we have to sort out where everything goes to write it in simplified form. So I can multiply the -1/2 and the 3 together, and that gives me -3/2. So the -3 is going to be in the top, and the 2 is going to be in the bottom. And then the 3x plus 4, I want to move to the bottom. So I've got a square root. That's the bottom part of the exponent. But then I've got 3x plus 4, and then that would be cubed is how you would write it. Okay? So again, remembering your exponent rules, if you have x to the m over n, it means the nth root of x to the m. Or also, you could write it as the nth root of x all to the m. But when you're simplifying something algebraically, usually you're going to use that format there, which is what we did. So the little 2 is the square root you don't need to show, and then the exponent is the 3. Okay, G. All right, so a little harder. Instead of a 1 on top, there's a 2. But you can still write this as 2 and then times 3x squared minus 5 to the negative 1/2. That's just y. That's rewriting it as a power function. So y prime negative 1/2 times 2 is negative 1 times 3x squared minus 5 to the negative 3 over 2. Decrease the exponent by 1. But then you have to multiply by the inner derivative, which is going to be negative 6x. And then you've got to write it with positive exponents or radicals. So I can multiply the negative 1 by the negative 6x, and that gives me positive 6x. It's going to be on top. And then the part with the negative exponent, I'm going to move to the bottom so the exponent becomes positive, and it's a root again. So the root of 3x squared minus 5 cubed is how you would write that. And there it is in simplified factored form. Okay, and H. So first we're just going to rewrite the function as a power function. So we're going to write it as x squared minus 5x to the, so that little 3 in there means the 1/3 this time. Then we can find f prime at x. So it's going to be 1/3 x squared minus 5x to the negative 2/3. And then we have to multiply by the inner derivative, which is 2x minus 5. And then we want to write it in simplified form. So in the bottom, we're going to have our 3 and our third root of x squared minus 5x all squared. And then in the top, we'll have 2x minus 5. And that would be written in simplified factored form. Okay, so here's a little bit of an application. Find the slope of the tangent to the curve y equals the square root of x minus 4 at the point 13,3. So first, to find the slope of the tangent, we have to find the derivative. So I would want to write it as a power function first. Then I would want to find y prime, the derivative. So that's going to be 1/2 times x minus 4 to the negative 1/2. And then times the derivative of what's inside, which is a 1. You don't have to simplify it unless it helps you to substitute the number 13 in, which I think maybe for me it does. So I'd have 1 left on the top, and then 2 times the square root of x minus 4 in the bottom. And then if I want to find y prime at 13, which is going to tell me the slope of the tangent at that point, it's going to be 1 over 2 times the root of 13 minus 4. One over 2 times the root of 9. So that's going to be, therefore, the slope of the tangent is going to be 1 over 6. All right, and number 3, find the equation of the tangent line to the curve y equals the square root of x cubed plus 1 at the point 2, 1. And that should not be 2, 1. If you put 2 in, you're going to get 8, 9, square root of 9 is 3. That should be 2, 3. My apologies. Okay. All right, so first we're going to find, or write it as a power function. So y equals x cubed plus 1. And then that's to the 1/2. Now we're going to find y prime. So that's going to be 1/2 times x cubed plus 1 to the negative 1/2, and then times the derivative of what's inside. So that's times 3x squared. And then if I multiply these together, because they're monomials, I'm going to get 3x squared over 2. So the 3x squared can stay on top and the 2 in the bottom. And then I'm going to move this term down to the bottom and make it square root of x cubed plus 1. So then to get the slope of the tangent, it's going to be y prime at 2. So 3 times 2 squared over 2 root 2 cubed plus 1. So that's 12 over 2 times, so that's the square root of 9. 12 over 6, 2 times 3, which is 2. So if we come up here, then we have therefore the slope of the tangent is 2, and the point is 2, 3. Because if you sub 2 in here, you get the square root of 9, which is 3. So there's my x, my y, and my m in y equals mx plus b. Y is 3, m is 2, x is also 2. And we get b is negative 1. So therefore, the equation of the tangent line is y equals 2x minus 1. Okay. Find the derivative in unsimplified form. So this is both of these questions are chain rule in chain rule. Okay, so I'm going to go through them slowly and carefully. And they're definitely asking for unsimplified form. So again, if you see a clue for unsimplified form, usually means that your derivative is going to be fairly complex. So first of all, this is like a power function. So we've got this function all to the power of 6. So by applying the outer, just doing the outer derivative, we know that f prime at x is going to be 6 times, doesn't matter what is that under that green line, we just recopy it. And then to the 5th. So there's our outer derivative. But now we have to multiply our outer derivative by the derivative of what's inside. So the derivative of what's inside. So the derivative of, we've got a sum here. So we can take the derivative of each part of the sum. So the derivative of x to the 5th is 5x to the 4th. That part's easy. But the derivative of this part here involves the chain rule, because it's a power function, 3x squared minus 2 all to the 4th. So to find the derivative of that part, The 4 comes down, the exponent, times 3x squared minus 2 cubed, and this is the part everyone forgets, because we're doing the chain rule here. We need to multiply that by the derivative of what's inside here. So the derivative of 3x squared is 6x. And then, so here's my big opening bracket and my closing bracket. So open, close, open, close, open, close. And that's why they say not to simplify it, because there's just a lot going on there. But that is your derivative. Okay, so this one's similar, but it's not ready to derive yet. We want to first write it in exponential form. So we've got, here's a bracket, and then here's this x plus, so then I'm going to do this part, x squared plus 1 to the half, then close my bracket, all to the half. So y prime, so first I'm doing, this is what's inside. So the outer derivative is a half, this half here comes out front, and then recopy what's in green, x plus x squared plus 1 to the half, close my bracket to the negative 1/2, so I reduce that exponent by 1. But now I have to multiply that by the derivative of what's inside. So the derivative of x is 1 plus, now just deriving this part here involves the chain rule again. So chain rule inside chain rule. So that's going to be plus a half x squared plus 1 to the negative half times, when I'm doing the chain rule, the derivative of what's inside, which is 2x, and that would be my unsimplified derivative. Okay. Now we're going to do a word problem that involves using the chain rule. An environmental study of a suburban community suggests the average daily level of carbon monoxide in the air can be modeled by the function c at t equals the square root of 0.5 times 3.1 plus 0.1 t squared plus 17, where t is the number of years from now and c at t is the level of carbon monoxide in parts per million, or ppm. A says, what is the expected level of carbon monoxide in the community 5 years from now? So they're not asking me for a rate at all, so they just want me to find C at 5. So that's going to give me 0.5 times 3.1 plus 0.1 times 5 squared, close bracket, plus 17. So you got to be able to put that in your calculator effectively. So I'd probably start off going 5 squared times 0.1, and then add 3.1, then multiply by 0.5, then add 17. So that's going to give me the square root of 19.8. Which is approximately 4.45 ppm. Okay, so what is the expected level of carbon monoxide in the community 5 years from now? 4.45 parts per million. Just make sure I've done the calculation right. And yes, I did. So square root of 19.8. Yep, okay. So there we are for A. B, so we'll try to put this up here over top. What is the average rate over the first 5 years? So that's going to be, so I'll do M average So that's going to be c at 5, which we just found, minus c at 0 over 5 minus 0. And we know c at 5 is 4.45 parts per million. C at 0, let's find that off to the side. So that's going to be the square root of 0.5 times 3.1 plus 17. So 0.5 times 3.1 plus 17, 18.55. C at 0 is going to be the square root of 18.55, which is approximately 4.31 parts per million if you round. And this is over 5 years. And then we can do that on our calculator. 4.45 minus 4.31 divided by, all divided by 5, is approximately 0.028 parts per million per year. So since it's positive, it means that the carbon monoxide, the rate is increasing by 0.028 parts per million per year. And then C asks for what's the instantaneous rate of change of carbon monoxide level when time is 5 years. So instantaneous rate of change, now we want to deal with the derivative. So I'm going to start off just by copying the function C at t the way we see it. And now we want to make it a little bit more friendly to derive. So I'm going to do two things here. One, I'm going to use brackets and to the exponent 1/2. But I'm going to also, because there's no exponent on the outside here, I can distribute. I'll use yellow, I think. So I can multiply the 0.5 by each thing inside there. And then I'll have some like terms, and I'll just make it easier to derive. So 0.5 times 3.1 is 1.55 plus 0.5 times 0.1 is 0.05 t squared plus 17, and that's all to the half. But 1.55 is a plain number, and so is 17, so we can add those together. So we're still just rewriting the function c at t and trying to make it as friendly as possible to derive. So that's going to give me 18.55 plus 0.05 t squared all to the half. So now I'm ready to find c prime at t using the chain rule. So the exponent comes down, 1/2 times 18.55 plus 0.05 t squared to the negative 1/2, and then I have to multiply that by the derivative of what's inside according to the chain rule. So the derivative of 18.55 is 0, but the derivative of 0.05 t squared is going to be, so 2 times 0.05 is 0.1 t. And then I might make it look prettier before I substitute 5 in. So on top is going to be the, I can multiply these guys together. So 0.1 times 1/2 is 0.05. So on the top I'm going to have 0.05 t. If I multiply those monomials together, and then this is going to move to the bottom and become the square root of 18.55 plus 0.05 t squared. And now I have to find c prime at 5 and be able to put it in my calculator properly. Okay, and then if you type that into your calculator correctly, 0.05 times 5 divided by the square root of 18 point, actually, I'll scroll back here, bracket 18.55 plus 0.05 times 25 closing bracket equals, and you get C prime at 5 is 0.056, and then therefore instantaneous rate is 0.056 parts per million per year. Again, make sure you have units for rates of change. Okay, in this case it would be parts per million per year. All right, so that is our first lesson on the chain rule.